Now, this is just kind of me telling you how the notation works, because obviously once we go into the Taylor series and the calculus behind it, it gets really complicated and it's unnecessary for this presentation. Although the calculus behind it isn't extremely difficult, although it is. Okay, so if we, like I just mentioned there, so that means if a vector is multiplied by the k-axis, because it's not commutative, if a vector is multiplied by the k-axis, that just represents a vector that was on the I-axis rotating to the j-axis, right? So it goes that way too. So if you see a vector multiplied by the k-axis, it's really just saying a vector multiplied by the I-axis rotates to the j-axis. Now the rotation is represented by, because rotations are commutative. Rotations are commutative, saying, okay, right here. Rotations are commutative in 2 dimensions, meaning that if you rotate something by alpha and then beta, then you can also rotate it by beta and alpha, which is what is this saying right here. K, a vector multiplied by k, is a vector multiplied by I, and it rotates it to the j-axis. Now these alpha and beta angles are going to represent the rotation. So what does this mean for physics? This means that since the Quternions follow the law of norms and they interact with calculus and algebra like we've always interacted with, they interact with them pretty much the same, except they're not commutative. We can go through the calculus of it, and what Cauchy-Riemann actually did was he made the Cauchy-Riemann equations, and I can go into the further partial derivatives that he took through there, and how he actually ended up making a zero, which is how Euler's equations. Anyways, what does this mean for physics? This means that we can redevelop all Maxwell's equations, all Newton's equations, all these equations that we've known that have been proved. We can redevelop them using Quaternionic notation, and we can reimagine electromagnetism, the wave equations, Schrodinger's equation. We can redevelop these with the Quaternionic units. And what Douglas B. Sweetser, which I don't know if I mentioned, but that's what I'm basing my research off of, what he's saying is that's going to give us a new understanding of unified field theory, and that's going to lay the foundation for unified field theory. So what's next? What's next in the proof? Next in the proof is trying to observe gravitons, because we know that for unified field theory we have to combine quantum mechanics with special relativity and somehow fit in gravity. So we have to observe gravitons, which is theoreticized, and we have to, since gravitons are to gravity as leptons and quarks are to the strong and weak nuclear forces, and electromagnetism is to particles and negative charged particles. So we have to redevelop all of our equations using Quaternionic calculus and Quaternionic algebra, and like I said, it follows the same pattern and the same, just the only difference is not commutative. So that's what it means for physics, and hopefully it will sound a foundation for unified field theory.